Hello everyone. I just learned something new. My job is to make sure you don't all fall asleep, or at least that's what I heard, right? So it is late, you've had lunch, so that could happen. I am the field CTO of a company called Snyk. If you're wondering, Snyk stands for, so now you know, SNYK. Did everyone know that? There you go. So now we all know, right? So what I'm gonna do today is you think about this. This is what we call the Cybersecurity Summit. And I'm only going to be focusing on one small part of that, and that's application security. But what I want to do here is articulate what some of the most compliant organizations across APJ have done to roll out an application security program that has been successful. Okay, so what we're going to focus on here, the slides are in front of me. So, top application security challenges for organizations. I'll be honest, what I'm going to bring up there is very relevant to FSI. But having said that, compliance and actually adhering to what the organization needs is important even outside of FSI. I'm going to talk about top considerations for leadership. What I mean by that is what's important to a CISO, but what's also important to a CTO. I'm also going to define successful, resilient applications. What have they actually done to reduce the security risk to their organization? And then what have we learnt? What are some of these, what could we do? What are some of the practices from what we've learnt that we could use our own organizations? And then I'm not sure if we'll have time for Q&A. So, top security challenges. I'm going to quickly flick through these. The first one is regulatory compliance. If you ever hear someone tell you, I need to scan my application, the reason for that is they need to tick off this regulatory compliance. Integration with third-party systems. With all the organizations that I talk to, they have to integrate with third-party applications. Not everything is developed in-house. So that's really important, so they've got to tick that off as well. Sophisticated attackers. Because I work a lot with FSI, within FSI, that is a space that cybersecurity attackers are spending most of their time. That's the most valuable data. Complexity of applications. If you can imagine, organizations have legacy, they have new microservices, they have complex application ecosystem that they need to support. Legacy systems, I spoke about that. Limited resources. I don't know if anyone's ever actually met the application security inside their organization. It's normally one application security practitioner, if you like, to 3,000 or so developers in some of these large organizations. So what's the number one risk for organizations? They want to mitigate the risk of security breach, yet they only have one person supporting 3,000 developers. Insider threats. Believe it or not, employees of an organization are a concern here as well. And then that secure customer experience. What that means is I want to deliver applications with velocity, fast. I want to make sure that I'm still competitive, but I need that to be a secure customer experience. I can't afford downtime, nor can I afford losing customers as a result. And that's also around release velocity. So applications have changed dramatically to what they were previously, to what they are now. But the one that I find the most interesting is, where is our real risk? Any tool can scan. Any tool can tell you, these are my open source vulnerabilities. These are my code vulnerabilities. These are my container vulnerabilities. But how do I know which ones I should be fixing? That's what I mean by increased complexity. Not only is the sheer amount of vulnerabilities high, I need to pinpoint which ones I should be focusing on. So let's look at it from a leadership perspective. We probably have a lot of CISOs in the room here today. For them, the most important is risk reduction. They want to go from 1 million vulnerabilities to maybe 1,000, or maybe 10,000, maybe 100,000, but that's most important. For CTOs, risk reduction is also important, but so is automation. You can't run a security program unless everything is automated around policy, governance, making sure that scans are running continuously, not just one-off as we deploy our application. So for CTOs, developer productivity is important because the developers are KPI'd on releasing applications to the business. So that's important to the CTOs. For CISOs, compliance is really important, and automation accuracy is also important. But for CTOs, which I find really interesting, is ease of use. I talk to development teams in organizations where they don't even know they're scanning their applications. It's almost invisible to them. That is really, really important. Okay, what does it take to be successful here? The first one is developer loved. It's really obvious. It's the developers that introduce the vulnerabilities. The developers need to love the scanning capability and embed it in their current software development lifecycle without impacting their ability to deliver applications to the business. So developers need to love it. If developers don't adopt it, no application security program will ever work. All it will do is highlight where the problem is, but we're never going to fix anything. The second one is security trusted. If I'm picking a vendor, I want to pick a vendor that has the most up-to-date vulnerability database, that has AI, machine learning, actually humans ensuring that the data is accurate and most up-to-date. The next one is delivering the fix. As a developer, scanning is the easy part. Every application security vendor out there has a tool that will scan, but delivering the fix and providing the remediation is the most difficult part. Imagine a developer sitting inside his IDE and he's being presented with a vulnerability and he just clicks on that vulnerability and fix it. That is the real value in terms of being able to deliver a fix. The second one is a comprehensive platform. There's no point in being able to scan across the whole software development lifecycle if we can't at any point in time understand where our risks are throughout the software development lifecycle. To do that, you need a comprehensive platform. You need to be able to integrate with a partner ecosystem as well, because no application security vendor can do it all. So integrating with partner ecosystems, I'll give you one use case, for example. Imagine you're presented with a bunch of vulnerabilities, but you don't have any idea what the runtime context is around, is this vulnerability even reachable? That's how you partner with an ecosystem outside of the application security vendor tool to reduce risk and ensure that you're focusing on the most important aspects. So there's a couple of pillars that I like to remind most people when I talk about DevSecOps success. Because that's what you're trying to do. You're trying to embed security into the DevOps process. DevOps has been around for so long, there's so much great tooling around DevOps that we can actually release software better than we ever could before. And it's not just the technology, it's also the people. Everyone's embedded DevOps into their current culture. Adding the security piece, I look at it with these 6 points. So the first one is DevOps Foundation, which we already have. Strategy and culture is really important. Secure design. What I mean by secure design is before a developer even writes some code, they're already thinking about security as part of what they're about to deliver. The next one is testing and monitoring. I need to make sure that I'm scanning all the time, even when I'm in production, and understanding what the threat looks like at any given point in time. Response and remediation. When I know that I've got a problem, I need to be able to remediate really, really quickly. And analysis and governance. Is my security program even working? What KPIs are we measuring? Where do we have issues where we're not streamlining security to meet the business needs? So all of these 6 makes up a successful DevSecOps program to me. You can't just have 1 or 2, you need to be able to tackle all of them. And when you do, you'll be able to just get this feedback loop and integrate security into development and continue to keep fixing issues really, really quickly. And believe me, when you're fixing issues early on in the software development lifecycle, it's a lot easier, cheaper, and you'll save much more money than when you have to fix it after the fact. The only exception here is a 0-day vulnerability. We don't know that a log4j vulnerability exists until it occurs. At that point, are we set up to be able to respond and remediate really, really quickly? And I don't want to be going to the dev teams and saying, do you have this log4j issue, this 0-day vulnerability? The tooling the DevSecOps processes should be able to alert that and provide the remediation, the ability to fix those issues, even automate the fixing of the issues itself. So I just want to focus on one of these, the DevOps Foundation, because we don't have time to go through all of them. It's a shared responsibility model. It's not just the developer, the security team, the business, everyone's involved in what it takes to actually deliver an application security program that meets the business needs. There's going to be processes and tools, so you need to clearly distinguish the difference between the two. So when we talk about tools and processes, we're talking about CI and CD, so delivery and integration, and all the way to when the developer is actually building the application itself. And the artifact and source control. Where does the developer's code exist? It exists in source code management. I need to be integrated there, and as changes are made, automatically block or at least provide where the problems are prior to going into deployment. Data-driven decisions. If I'm scanning all the time and I have enough risk factors, I understand that these are public-facing apps, there's a mature exploit, there's an EPSS score that's high. Taking this data, I can then make that part of my DevOps foundation, ensure that I'm actually alerting and fixing the most critical issues themselves. And we always want to improve. We want to monitor, observe, and change, right? So that feedback loop that you're seeing here on the right is exactly that. And we want to automate tasks and processes. This has to be something that is just part of your given operations all the time. We can't just be saying we've got these security issues and send a report to a business unit. That's just not going to work. Okay, so what have we learned? It actually takes a platform or a governance platform that actually looks like this. And what I'm going to do is I'm going to start at the bottom. So if you look at application security, that's just the tooling. That to me is a given. The ability to scan, get the results, and provide the remediation. But the business demands more than that. They want reporting and analytics. How many dev teams are actually introducing new issues that could have been prevented? Or how many dev teams have improved their security posture by 50% in the last 3 months, for example, or their mean time to resolve issues? Policy and automation is really important because at this point, I'm going to block anything that doesn't meet our security policies. And that's not just, I'm going to block every critical issue, but I'm going to block a critical issue if it has a fix, if it's a public-facing app, or it's an application that the business demands that there are no vulnerabilities in terms of going into production. All that wrapped in a DevSec governance platform that then has the CI/CD, software development lifecycle, all that, as well as being able to do this in the cloud and, code, IDE, all of this ecosystem sits around that to make it happen. And the customers that I work with, if they've got a DevSec governance platform, that gives them the best opportunity to run a security program that meets the business needs. That's more than just picking a vendor to say, right, can you do this for me? I need all these pieces in place as well. And if you're wondering in terms of application security, what that is, because it's just a box down the bottom, that's my open source scanning. That's my scanning of the code, SAST, so SQL injections, cross-site scripting. That's my scanning of artifacts being the container images themselves. What I find the most interesting about container is, if you think about it, you're using open source libraries. You've got your own code, which I call the first party code. You package that and you put it into a container. You go from 10 vulnerabilities, 20 vulnerabilities, that's 30. You put it into the container, you've got 230 because the container has its own 200. How important now is it to be able to identify where the vulnerability is and whether or not it should be fixed? And that's what I mean by a DevSec governance platform itself. I want to finally talk about something called risk-based analysis. So I work with organisations, and this is one of the largest banks in Australia. They had 1.1 million vulnerabilities after they set up scanning of all their applications. So they set up scanning in their pipelines, they set up scanning in their source code management. They had 1.1 million vulnerabilities. They came to me and said, Pass, how do I tell the developers which one they should be fixing? Because there's no way they're going to fix the whole 1 million. There wasn't time. So they're drowning in issues, is what I'm trying to say here. And this is what it takes to make something like this happen. If you're able to build an application graph, this component talks to that component, this component is public-facing component, this has this network. If you gather all that information, you can actually calculate the risk score. As soon as you calculate that risk score, you can then start to answer questions as to which issues should be fixed first and why. So if you think about it, if I've got an open source vulnerability, which means that I'm using an open source library that has a vulnerability, I don't want to fix that issue if my code's not even going to invoke that library method, right? So reachability is a big thing. Also, if I've got an application that's deployed, let's say it's deployed on Kubernetes, and it's actually on a network or it's a back-end container process running that Kubernetes platform, I don't need to fix it because it's not even public-facing. What if there's no ingress endpoint? All of these factors around the calculated risk score and the app graph gives you the ability to be able to narrow down. And I know because I work with this bank, they were able to talk to the dev teams and say, out of these 30,000 issues, these are the 300 issues you should be focusing on. And out of those 300 issues, how many do you think they fixed? All of them? It's only 300 issues. They only fixed 80% of them. And the reason they only fixed 80% of them was because some of them they could safely ignore based on all that calculated data and risk that they were given, right? So really, really important. So when I say that they fixed X amount of vulnerabilities, they only fixed the ones they knew they had to fix. The rest was safely ignored. That could be ignored forever or could be ignored for a few months, and we'll come back to this at the appropriate time. There's the 80% reduction. I want to tell you about what 2 customers did with using all of these principles that I explained. By the way, I forgot to mention this. The last guy was in Australia, and I'm based in Australia as well. Just in case you weren't clear from my accent, I'm definitely Australian. I might not look Australian, but definitely from the accent. So this one customer, they were focusing on a secure customer experience. This was a leading bank. In fact, 50% of all financial transactions in this one country alone went through this bank. So that's a lot, that 50% of transactions. They wanted to improve their NPS. Now, NPS can mean a lot of things, but what I mean by that is they wanted to make sure that if there was an unplanned downtime because of needing to patch something that wasn't tested previously, they wanted to make sure that it was fixed earlier and there was no unplanned downtime. As a result of that, they were able to reduce their NPS score by ensuring that the developers were fixing the issues using actual AI to fix the issues, single click of a button, using Copilot, all that sort of stuff, to make sure that their NPS score would be lowered as a result over time. Because the only time you really want to take a system down is if something has gone horribly wrong that you never saw. But when you knew through the software development lifecycle that this issue could have been prevented, they wanted to make sure it's prevented before it hits production. So that was really important because that, from a business, you're only implementing tooling or an application security program to solve a business need. In this case, they wanted to achieve faster releases with greater customer satisfaction. The next one on the right-hand side, we're nearly finishing here, so I've got 1 minute. Regulatory compliance. So another really large bank, again, doesn't need to be a bank, it could be retail, there's many different industries that application security is important for. They wanted complete visibility and user-friendly tools. So remember I said that the developers need to adopt this and integrate security into the development team. They actually deployed tooling for 3,500 developers. That's developers at scale. I've worked with organizations that have 10,000, 20,000 developers, but that's still high. They were able to deploy the tooling in under 6 months, leveraging automation to scan over 10,000 assets. When I say assets, that's containers, their source code, these are all considered as assets themselves. They were able to achieve an 80% reduction in vulnerabilities within 3 months post-rollout. That was the organization that went from 1.1 million vulnerabilities down to 100,000 vulnerabilities. So the benefit was to the business, this is the reduced risk, so it was really, really important that I did that. I have 22 seconds and I'll finish right on time. Was I the first person to finish on time? Well, there was others. But that's it from me. Thank you.